Today we will use two methods of writing program on ATmega2560. We take two LEDs and apply two methods of programming to make them blink. Before that, we should know the difference between an Arduino board and the ATmega2560 microcontroller. Arduino Mega 2560 board comes with a microcontroller as its heart, plus some more peripheral systems and terminal pins brought out from the microcontroller. The developer has supplied a software with the help of which we can write a program for the board to work. At this, we include some header file called available functions, develop application. This style is the Arduino style of programming. There is another style of programming. In this style, we target the registers of microcontroller, develop register level program, and get our job done. Today, we will apply both types of programming to blink one external LED and the onboard LED already available. However, before proceeding, we should note that an external resistance must be connected to LED in order to restrict its current. This current may come from the port pin of microcontroller called current sourcing. Otherwise, the current may go into the pin also, called current sinking. For high current LED, the port pin may not be capable of carrying high current. At this, an indirect drive of current is applied by connecting LED through a transistor. The port pin delivers low base current or gate current, and the high current is delivered by the biasing supply itself. Now, we use one LED to be connected externally. The longer lead of LED is its positive terminal, that is anode. The shorter lead, on the other hand, is negative, that is cathode. An external resistance of 220 ohm will be sufficient for our purpose. If the rated forward current of LED is not known, it is advised to start with a higher resistance. Resistance value needs to be progressively reduced to enhance current and hence glow. Here we use pin 22 of Arduino board to connect external LED. The onboard LED, however, is always fixed at pin 13. For register level programming, pin 22 of Arduino Mega 2560 maps to bit 0 of port A, and pin 13 of Mega board maps to bit 0 of port B of ATmega 2560 microcontroller. The mapping of pins between Arduino board and ATmega 2560 microcontroller is available in datasheets and internet. To configure port pin, a logic 1 has to be sent to its corresponding data direction register, that is DDR. Using a breadboard, we start connecting an external LED to our microcontroller. Now we use proper USB cable to connect microcontroller board to computer. Our next task is to write program on the editor window of Arduino software. For this, it needs to be installed first. We just type Arduino software in Google to search the required installation file. The required file is downloaded now from appropriate web page. Double-clicking it will serve our purpose. An Arduino shortcut is generated on our desktop. Next, we connect the board to our computer via the USB port. In Tools menu, we go to the option named Board and select Arduino Mega 2560 board. The COM port with the available numbering needs to be selected also under the option port. Common should not be selected obviously. The editor window contains a default structure for program, namely setup and loop. Anything written inside setup is executed only once. The instructions written within loop, however, repeats forever. Now, inside setup, we write our instructions to configure port A as output. At this, the pin 22 will be set as output pin also. Within the loop, we load port A with any byte that sets and resets bit 0 alternately. In between, some delay in millisecond is inserted. Except the delay command, all other instructions are register based. We complete writing the program and press the shortcut button of upload. Once the compilation is over, the sketch is uploaded to the board. Now, the LED starts blinking. The same program is written in Arduino style. Here, the function pin mode configures the pin and the function digital write sets or resets the pin. All the functions have been written already by the developer of the software. Now, the onboard LED connected to pin 13 will be used. The program is written in Arduino style now. After uploading, the onboard LED starts blinking. The register level sketch is shown where DDRB and port B are used. The delay function can obviously be replaced by register level programming, but presently we are using it to simplify our job. A separate video will be published later to develop code for replacing delay.